Today on the Beam channel, I want to talk about context-free grammars and what they are and how you use them. But before I do, I would say if you need help with Erlang or Elixir, please feel free to give me a shout. I can help you and your team out with training courses and a number of other options. If you've been programming for a while, you've probably used a regular expression. Regular expressions are great. And you've probably occasionally either asked or seen somebody else ask, how do I match HTML with a regular expression? Or how do I match some other more complex thing? And the answer is you can't. Regular expressions match regular languages. Regular languages are defined by a finite state machine, and HTML is not a regular language. HTML is a context-free language, as are many other things. A context-free language is something that's defined by a context-free grammar. And by the way, if you've taken freshman computer science somewhere, you've probably seen some of this before, and there's a lot of stuff that if you take freshman computer science in here that they would go into in great depth, and I'm going to sort of wave my hands over. So, you can go out and learn more if you want, go to Wikipedia, and so on. A context-free grammar is a grammar defined by a set of recursive rules that looks something like this. So let's say we wanted to match a grammar that can have matching parentheses, nothing else, just parentheses that match. So you always have a left with a right. You can never have a left, one without the other. So you might have a set of 4 rules, where we're going to start with the symbol S, which is just an arbitrary symbol. And S can go to epsilon, which is the Greek letter epsilon, which is the notation for an empty string. S can go to SS, so we can replace it with 2 of the same. S can go to parenthesis S parenthesis. And S can go to parentheses with nothing in them. So anything that can match any of those 4 options becomes a valid string in this language. So you could have the empty string, epsilon. You could have a string that's just a pair of parentheses. You could have a string that is 2 parentheses, a parenthesis, then another an open, close, or open, close, and so on and so forth. But you can never have mismatched. So this is a very simple, obviously, for the sake of this video, context-free grammar. Now, let's take a slightly more interesting one and take a 4-function calculator. So this can do basic arithmetic. We will take, add, subtract, multiply, divide, and parentheses. And we're going to do it over. Now let's take a look at that. So in order to work with this, we want to start with a string like this. Let's start with a string like 12 times 2. By the way, all the examples are going to come out to 24 here. No particular reason, just because. The first thing we need is Elixir. Elixir takes this and breaks it up just into symbols. So the first thing symbol is the number, is the characters 1, 2, which we convert to the number 12. And then we have the multiplication symbol, the time symbol, and then we have 2, which we convert to the number 2. So the Elixir just gives us a list of symbols. Now, in Erlang or Elixir, we create Elixir using, so here's how we build Elixir to sort of handle this language. We create a .xrl file. This is going to be called elixir.xrl in the source directory. This is where Erlang expects things. Mix and Rebar both know how to compile this down to an Erlang file and then down to Beam code. So this is going to create a Beam module. So the first thing is we put definitions, and these are defined as regular expressions. So we're going to say number, which can be either optionally with a minus, and then 0 to 9, 1 or more. And this is just to give you integers. And then white space, and then line breaks. And then we have rules. And rules say, I took these modified from some online blog posts, by the way, say what to do with them. And you can see that basically they turn them into tokens, which is either number, token line is the line in the file, and we can just sort of turn them into the value. So list to integer takes the function list, takes the numbers 1, 2, for example, and turns it into an integer of the number 12. And then down at the bottom, we have some Erlang code. Now this basically just gives you a list of symbols. Now, if you went to school in the United States, depending on what decade you did, you may have then had to diagram sentences, which is what the next part does, the parser. Now the parser, which is YEK, is based on, takes a grammar in a context in what's called the backlist NOR form, and it looks something like this. And then, so we have non-terminals, these are things that expand into other things at the top, and then terminal symbols, which are just literal symbols that we get out of our Elixir. The root symbol is what you the start place, and then a list of grammar rules, and each one starts with a non-terminal to some syntax, and then after the colon is some Erlang code. So here it turns it into a set of tuples, and the $1, $3 basically refer to the first thing. So if you look at the first rule, expression can be a term, $1, or expression can be expression plus, where plus is the addition operator, and then another term, so that you can then say add $1, $3, and so on. And this basically expands recursively. And then what happens is the YEK code turns this rather small thing, which is 10 or 15 lines of code, turns into a ginormous Erlang file. You don't have to worry about that too much. It handles it automatically. From there, you have a parser. And the parser puts out an abstract syntax tree. So here is the code that we actually do the calculations with. So YEK, being an Erlang program, expects characterless Elixir strings. Fine, we can do that. And then we can just lex the string, and that gives us like a list of symbols. And then we're going to then parse it, and we're going to get OK an expression. Now this is going to give us an abstract syntax tree. And then I've written here some code that actually takes that abstract syntax tree and turns that into an actual evaluation. So at the end of this, we should get a number out. And you can see here from the test code that, and this all pass, that each of those will run a different way and pass. So the first thing you'll see in the basic lexing is we're just going to lex the code here. You're just going to get the list of symbols out. But then you're going to get a calculate, which will actually do the whole thing. And you end up with a calculation. Anyway, I will post all the examples in the gist or in GitHub, so you can actually go through this in more detail. Lexing and parsing of files is actually very old tech. This has been around since the 70s in the C world. You can find countless references, and it works really well, and it's used in a lot of very critical things. So if you're building a domain-specific language, this is stuff you might want to look at. If you aren't, you probably will never need to know this stuff, but it's one of those things you feel like developers should have in the back of their heads somewhere to keep track of for the future. So anyway, I hope this was useful. I hope this was interesting. I hope this broadens your horizons a little bit. If I can be of any service in the future, please feel free to give me a shout.